Rehgan is co-founder and CEO of AlignAI. AlignAI is a company that she started, how long ago now?
5 years ago.
5 years ago. And Rehgan's out of Columbus. What they do is, and I better read this because she's going to say, geez, you didn't get that right. It's a platform for helping enterprises get value out of AI quickly and safely. With a decade of experience in this space, she has worked with highly regulated companies to design and architect data and AI solutions. She's a regular keynote speaker, has done keynotes at over 50 conferences. But in addition to her role at AlignAI, she's also the founder of Women in Analytics, which holds a fantastic conference every July, I want to say, and global organization, and this community has about 7,000 members, and hosts a global conference that has put about 250 women on the stage. So I want to welcome Rehgan, and who is going to talk about AI.
Thank you so much.
Thank you, Rehgan.
I'm going to keep my phone here because anyone that knows me knows I talk a lot. So I'm going to make sure I don't go over. I know they're getting set up here. Awesome. Thank you. Appreciate it. So I'm really excited to do this talk today. This is a brand new keynote for me, so custom for all of you. Designed it with kind of the content in mind that you're going to listen to today throughout the day. And I'm going to take you on a little philosophical journey, just a little one, in the beginning. And then I promise we will get into the fun, nitty-gritty things. So I wanted to start with a personal evolution with data science and AI. I started building models, machine learning models, a little over a decade ago. And I started with things like TensorFlow and Jupyter Notebooks and Python, even though while I was in school, they were trying to get me to build machine learning models in Java. Anybody done that before? Yeah, no hands. And I was building models that were like classification models, clustering models. And so I was very much in the model building phase and the teaching phase. So I would travel all over the US. I would teach at different MBA programs to help mostly students or MBA individuals in finance, and helping them to use machine learning for different projects they're working on. So teaching finance people to code, which was super fun. And then from 2016 to 2019, I moved on to this company called ModelOp. Has anybody heard of ModelOp before? Okay, one person, love it. We were pretty early to the market for machine learning ops, right? And this was basically transitioning from model building into putting models into production. How many of you have built a model that never made it to production? Lots of hands. Yeah, it's a hard problem. And then I focused a lot on governance. So I was thinking kind of holistically about governance. And when my co-founder Brendan and I started AlignAI, most of what we were focused on was, okay, it's hard to get models into production. Why is that? And as a technologist, I thought about all the technical reasons why it was hard to get models into production. But thinking more philosophically, I was thinking about why is it so hard to prioritize getting models in production? We were working with these big banks, so there was a lot of regulation that we had to get through, and a lot of technical complexity. But on top of that, a little anecdote, we would bring the models to the and we would say, look, we're really good at predicting prices on municipal bonds. Isn't that amazing? We built this clustering model. Here's what it does. And I remember distinctly one of the traders was like, yeah, you're here to replace me. And I was like, I'm actually here to make your work more interesting. Because what we did was we built a model that helped them automate all the easy ones, where they could spend all of their time on the hard ones, all the nuanced trades. That's where they really wanted to spend their time. They didn't want to spend time on the easy ones. So I became kind of obsessed with this idea of like, what does it take to get people to adopt these solutions? And that was the premise of AlignAI. focusing on AI adoption and governance. Now, like I said, I'm going to take you on a small philosophical journey here. So that's where I'm going to start, a brief one, hopefully. And then we'll go into some of the technical shifts that have happened over the last decade that I've observed, and a little bit of where we're going. I'm going to spoil that in keynote. He's going to spend most of his time on that. Like I said, brief. Keep me honest. What does it mean to be intelligent? This is the existential question, right? And as I've done a lot of these talks across the country, I've interfaced with a lot of technologists who have argued with me a ton on this question. Oh, that's not AI, this is AI. How many of you have a very solid definition of artificial intelligence you feel pretty good about? Great. Nobody. Perfect. You're not alone. And this is why it's so hard to get leadership and executives on board. What is this? What are we trying to do? You've got some people who are saying machine learning is AI, AI is machine learning. You know, it's very complex, right? And then where does data science fit into this? And how does that, you know, engage with those different terms? And so we're going to try to solve that a little bit today. But like I said, no one has a really solid definition, which as mostly mathematicians and statisticians is kind of mind-boggling. We love definitions. So has anybody read this book, God, Human, Animal, Machine? It's a very good book. It'll make you think, you know, it might take you down some spirals. I'll just say that. But I love this quote. The quest for artificial intelligence is, at its core, a quest to understand ourselves. This is why I got into this space. The second I realized that we could use data and machines to model the world or to model humans, I was fascinated. I was absolutely hooked. So if we think about what does it mean to be intelligent, when we think about that with humans, we might think about creativity, novelty. We might think about reasoning and problem solving, or creating a world model that you can improve upon over time, or understanding or constructing abstract concepts, or even self-awareness and EQ, although I'd argue, you know, not everybody does that. Or your capacity to acquire, store, and retrieve knowledge, or planning and decision-making, or your ability to learn. And these are the existential questions that we have as we're building these technologies. How do we know we've built AI? These are the arguments I usually get on the whiteboard with these technologists or over a beer. And it's really, we haven't built it until these things are true about that system, right? But unfortunately, this has been an ever-moving goalpost. We have thought for years, decades, what AI is. And when do we know we've gotten there? Right, the Turing test in 1950, which I'll show you something fun here in a second. Or in 1997, with AI beating someone in chess, Garry Kasparov. Or in 2015, when image recognition surpassed human capabilities. Or language understanding surpassed human capabilities. Every time we think we're hitting AI and we say, it'll never be able to do this, we surpass it. So where are we going? What have we not done yet? Reasoning, autonomy, adaptability, these are things that we are still trying to systematically design. But I want to share this quote with you. This is translated from French, but this is with Garry Kasparov, the master chess player. And he was asked, you know, will a computer be world champion one day? And he says, ridiculous. A machine will always remain a machine, that is to say, a tool to help the player work and prepare. Never shall I be beaten by a machine. Never will a program be invented which surpasses human intelligence. And when I say intelligence, I mean intuition and imagination. This is how he defines it. Can you see a machine reading a novel or poetry? That's happened already. But better still, can you imagine a machine conducting this interview instead of you, with me replying to its questions? That's also happening, right? So we keep moving the goalpost. So when we keep talking about AI, what is it? How do we define it? What does it mean? Has anyone seen this video? You should look it up, it's pretty funny. It's a reverse Turing test where somebody made a simulation of all these historical figures in a train car. And the goal, so each of these historical figures is a different model. So one's like GPT-4 and one's Claude. And there's one human. So instead of a human trying to identify whether it's AI or human, we're now asking AI to identify the human. It's actually pretty funny. And the biggest thing that I took away from this simulation, as they're all having discussions with each other, including the human, is you can immediately tell who the human is. Because the human has really concise ways of speaking, maybe not great recollection on historical facts, whereas these models are very verbose, very accurate. They're talking about very specific things that they've done historically. So I'd argue this kind of surpasses human capability in that regard. So when we go to define it, we hear all these words tossed around. And the best definitions that I have seen or observed is that AI is the ability for a machine to be very good, if not better, than an individual on a particular capability. Information retrieval may be one of those. AGI being a machine that is good broadly across many capabilities, virtually every capability, and better than the average human. I would argue we're not quite there yet. So then what's artificial superintelligence? Also another term coming up lately. It is the ability for a machine to surpass a human at every task, every capability, the best human, in terms of intelligence, right? And so when we think about what is AI, does that relate to everything else? Do we have AI today? Yes, in terms of those definitions, right? So why language models? Why are we so fixated on generative models, language models? I would argue that language models provide a construct or proxy for a worldview. Jan LeCun talks about this a lot. In the models, he's behind Meta's AI group, right? And he talks about building these foundation models that can generate world models that we can then extract information. All of us have world models. All of us perceive things, we built things, we have them internally. And how do we learn about new concepts and ideas? We read, we listen to podcasts. It's language. So we take very abstract concepts from our brain and we disperse that through language. It is one of the best ways that we can translate ideas and thoughts. And a lot of people are seeing that very similarly with language models. So when you're thinking, why this obsession with language models? This is why. So we start to think about this idea of, is it just imitation or is it real, and what does that mean? This metaphor of humans has lived on since the beginning of time. We've always tried to create metaphors to understand ourselves. And seeing ourselves as machines became popularized in the early 1920s. So if we start to think about ourselves as machines, we can start to kind of understand how we work and replicate ourselves in machines, right? And that's why we've coined terms like neural networks, processing. We say our brains are processing, but that's a technical machine word. So when I typically talk to people, I use this paradigm, I'm guilty of it, and it does truly help people to understand what's happening under the hood. So for non-technical folks, I usually show these three things to my executives, right? You've got input data, you've got models and storage, and you've got prediction and action. If we break it down very simply, we're kind of living in these paradigms when we're building these systems. And I use this example that everyone can relate to, which is defining an objective or a goal, crossing the street quickly and safely. And when we do that, we have tons of input data. We're looking for cars, we're looking for signals, parents maybe, if we're being taught not to run across the street. And then our brains create these pathways that create learnings, and over time they become unconscious decisions. And then we make those predictions. And every time we go to cross the street, we're predicting with high probability that we're not going to get hit by a car. And then we decide to go. And so when we're thinking about this parallel between the systems we're building and what we're doing, we actually need to be extraordinarily conscious of the things we're doing that we're trying to model in the machines themselves. So let's get down to the tactics a little bit. That was my brief philosophical journey for you. And we'll ground ourselves a little bit in some tactical learnings today. So this concept of machine learning, we talked about AI, right? What is machine learning? And I just say simply helping machines to learn, right? It's pretty simple. If we look at this diagram, we're basically saying we're going to feed it a bunch of examples, input data, and in supervised machine learning, we're going to feed it tons of labels, purple, purplish blue, versus orange, right? And those are our labels. So we take inputs, we show examples, and we say, here are the outputs. Here's what you need to look for. Create some patterns. So why do we do machine learning? Well, I'd argue we're pretty good at picking up on patterns. Humans are. But machines are better at detecting complex patterns that we potentially can't pick up on. And that's why we use machines for that. And in addition, they can process data much faster than our brains can. We're actually very selective in the way that we process data. And actually quite efficient. Machines are very inefficient at this in terms of, its power versus its output. And so when I think about machine learning, I kind of give examples of we're feeding tons of examples or observations, and we have these expected outputs, go find some patterns. And everyone here should be familiar with the data science process. So when we're talking about data science holistically, I think of it as a process. I am conducting data science, I am doing a process, I'm going through a process. This illustration is by Hilary Mason and Chris Wiggins, if anyone's familiar with them, kind of OGs in the space. And so this process is obtaining data, scrubbing data, exploring data, modeling, and interpreting, which I'd argue is probably the hardest part of this whole thing. So let's move into some technical shifts over the last 10 years. We've kind of defined what AI is, we've defined what machine learning is, we've talked about the data science process. Now, what has changed in the last 10 years? And I'll just caveat this discussion, this part of the discussion, by saying that some of these things aren't new, but they are seen or observed more often in the wild. And so when I talk about these things, it's not that they're net new, it's just that more and more people are leveraging those techniques. So we're going to talk about data, of course. We're going to talk about architecture, testing and evaluation methods, and risks. Let's start with data. We've gone from gigabytes to terabytes. It'd be a surprise to nobody. And really, the three core things that have shifted are variety, quality, and volume. So when we think about where we were in the last 10 years, again, relative, keep that in mind, the variety was fairly low. Lots of relational data, lots of structured data. Quality was somewhat simple to calculate, right? How many nulls do we have? How many missing values? What's our accuracy? And then volume was kind of medium relative to today. So we're talking about much smaller data sets, things you can open in Excel, right? Now we've got high variety data. We're talking about multimodal data, images, audio, and text, in addition to numerical values. We've got an increased level of complexity in this data. High dimensional data, sensor data, IoT data, and very, very, very high volumes of data, right? To build these foundation models, these language models, they are scraping the internet for tons of text data. Data is the crux of all of this. So So when we look at data collection sources, especially for LLMs, for large language models, we're talking about user-generated content, public data sets, code repositories, synthetic data, domain-specific data sets, licensed data, which has become more and more popularized, right? So we're looking for these very specific observations of these domains, because when we're thinking about building these AI systems holistically, the more context and the more depth in domain, the better it becomes at these nuanced problems. Next, we'll talk about architecture. This is where I spent a lot of my time as a solutions architect, and thinking about how to get these darn machine learning models into production, right? And these are kind of the three pieces that I've seen shift over the last decade: dependencies, scalability, and optimization. In the last 10 years, we've had a tremendous amount of code dependencies, especially in the open source world. Part of the problem of getting these models into production was that they relied on a very specific version of a package we used in Python in development. And if that doesn't exist in production, or if that changes, we've got problems, major problems. Scalability, fairly low. We could run a lot of these models on our laptops, no problem, which was also the problem, actually, because a lot of data scientists would just run these models on their laptops. These were making critical decisions for large banks we all use, and they're being run on laptops. And optimization, fairly static. You'd be lucky if you get to retrain this twice a year, right? Updating the information that it has access to. How do we make improvements to it over time? Now, we have dependencies on models. That's kind of a wild paradigm shift. We are now dependent on these LLMs, these foundation models, where we can then leverage those on and build on top of it with things like transfer learning. We've got highly complex systems. Scalability needs are super high. Everybody knows about the GPU problems, right? NVIDIA's loving that. And then we've got dynamic optimization. We have things like, reinforcement learning with human feedback. We are trying to dynamically improve these models over time. Every time you tell ChatGPT, no, not like that, more like this, you're improving the model. It's pretty incredible. But this creates a lot of challenges. We're also dealing with more real-time systems instead of these batch systems that we would run maybe once a week and process this relational data once a week, right? Now we're dealing with real-time use cases. We want that answer immediately. We're dealing with latency problems. We have to go down to the infrastructure to try to fix some of these things. And I'll argue this constraint on infrastructure has actually created a lot of cleverness, creativity on the architecture side to try to overcome that. These are kind of drastic oversimplification, but kind of what these architectures looked like that we were trying to build for these banks. Raw data, data processing, feature engineering, feature store, training data set, new data, training code, scoring code. These weren't hard in terms of, architecture. Now we're dealing with complex architecture, very complex architecture. This is a diagram by Chip Wen. Anybody familiar with Chip? She's awesome. She's got some incredible books about MLOps and LLM ops and getting models into production. If you're ever interested in diving down that rabbit hole, she's a great resource. swenchip.com if you ever want to dive into it. But you look at how much more complex this is. We're dealing with guardrails. We're dealing with output guardrails of safety, verification. We have model gateways, right? We want to switch between models, or we want to create that layer of abstraction so we can exchange models based on what we're trying to do. If we have a model that's really good at one task and a model that's really good at another task, we want to switch those out. We're dealing with vector databases and vectorized data and highly unstructured data. We're now needing to use cache architectures to make sure that we can be cost efficient about the things that we're doing. These architectures get much more complicated. So we're dealing with levels of complexity at a magnitude that's much higher. And testing and evaluation, arguably one of the harder pieces of this whole thing. What is good? What does good look like? So the evaluation techniques are changing and developing. Interpretability of these models are going down and is a huge problem. And monitoring the performance of these things is also really hard. In the last 10 years, on evaluation, fairly objective, right? We're looking at R squared, squared error. We can calculate this. We can create a confusion matrix, and we can calculate our false positives, our false negatives. How good is this model? Interpretability, fairly high. We're using, pretty simple techniques. And to be clear, these techniques are still very useful. I'm not arguing that we abandon them. In fact, most of the projects that we work on include these techniques. And then we get into monitoring. We just set thresholds, what's acceptable, what's not. If it dips below, let us know. We'll retrain it or dig into it, right? Kind of set it and forget it, and then alert me when it's wrong. Now, we have very subjective evaluation techniques. How good is this model? That's subjective. Who likes Claude more than OpenAI's model? Okay, a couple people. Who likes OpenAI's model more? A couple people. See, right, very subjective. The answer would be why. What are you trying to do with it? What tasks are you trying to accomplish with it? Interpretability, very low, as I mentioned. Why is it doing what it's doing? Right? Is it logical? Does it matter? If we get the right outputs, does it actually matter if it's logical? And behaviors. We're monitoring behaviors now. We cannot keep our eyes off of these models. We actually have to interrogate them in production because we need to find if there's issues with them that we haven't uncovered yet. There's, a thing called model toxicity. And there's been tons of research papers that have been studying or looking at how do we detect toxicity. And one of them showed that they tried every test that they could possibly think of. And there were clever ways that the information was buried in the model that only came up in a very specific scenario. And when that scenario happened, it comes up. That's a huge problem. How do we find that? It's like a needle in a haystack. Is anybody familiar with Big Bench? Benchmarks for these large language models? This is one of the benchmark standards that's out there today. There's I believe over 400 people contributed to this in over 100 institutions. It has, I think, at the time that I looked, it had 204 tasks that it basically used to test capabilities of these language models. So you'll see the keyword, number of tasks, and a description. Things like contextual question and answering, summarization, conversational question and answering, reading comprehension, word sentence, text simplification, paraphrasing. So these are tasks that they have determined would show capabilities, and they've calculated good, what their interpretation of good is. Now, this is a really, really hard thing to do in terms of creating kind of statistical evaluations of these models. Imagine how we assess people today on their reading comprehension, right? It's nuanced. It's not straightforward. And interpretability, I mentioned, when we get down to the basics of the techniques that are being used, we have things like linear regression and decision trees and logistic regression kind of at the top where we can interpret the results a bit better. We can look at which features are weighted more heavily in these decisions, right? When we get to neural networks, we cannot. And there's a lot of research being done in this area, in this domain. And interpretability is important for a couple of reasons, although I'd argue it's getting less and less of a requirement. So in a lot of these regulated industries, you'll hear that they're not allowed to use neural networks because if, for example, you're using a model to predict whether or not somebody might default on a loan, and you deny them of a loan, you're legally obligated to tell them why they've been denied. And the answer as to why could say, look, let's go back to our model, interpret the results, and tell you that this feature was pretty heavily weighted, and this is the reason why we're denying you. A neural network would not be able to do that. You might be able to interrogate it and see if it would give you the right answer, but we don't have that level of interpretability. And in some cases, people say, who cares? Was it right? That's kind of dangerous in some ways, right? Now to get on to the risks, because these risks have definitely transformed over time. And with my governance background, I think about risks all day long. I also married someone in cybersecurity, so my entire day is just paranoia. So same problems, new exposure. We've got kind of these three dimensions of compliance, ownership, and security. Now, compliance in the last 10 years has been fairly loose. Again, relative, think relatively. Ownership, pretty well defined. We build models in our walls with our data and a story. Security, straightforward, mostly. Security is never straightforward, but again, relative. When I would sit down with these security teams at these banks, we would take a look at the architecture and they're like, here's an access point, here's an access point. Let's create a system ID between this point and this system and that system. Call it a day. Here's who owns it, here's who can access it. Where do the outputs go? How are we doing access controls around the outputs? Fairly straightforward. And even maybe running locally or running on-prem. So behind the firewall, right? But now we're dealing with very strict compliance. We're dealing with things like GDPR and the EU AI Act. And so anybody in the EU, if you've got customers there, if you've got plants there, if you've got facilities there, there's a lot more regulation, a lot more red tape, which is in some cases very good, and in other cases prohibitive, right? Ownership is pretty blurry. Lots of people are getting mad, right? Their content is being used to train these models. Is that a good thing or a bad thing? Do you own that? Who owns that? Did anybody see the whole LinkedIn debacle where they were like, hey, we're just going to automatically train on all of your content? Everybody got really mad, and they were like, go in and turn this off, here's how you do it, right? Like, we've seen this story over and over again in the last year, 2 years. Happened with Zoom as well. There was kind of this big debacle, and they had to come out and publicly say, like, we're not training on your meetings. So, I mean, the ownership piece is a big deal. I'm spending a lot of time with cybersecurity analysts and with legal teams talking about this. And it's so hard to think about because, like I said, models are now dependencies. So we are now dependent of our systems, if we're using large language models, on these models. And they may have issues with ownership. In fact, Italy banned ChatGPT because it was a violation of GDPR. Part of your right under GDPR is to inquire for your data and be able to delete it. You can make a request to actually have your data deleted. Can't do that in these models. That data's in there. To get it out would be very hard. It'd be like me telling you my password to all of my stuff and then telling you to forget it. You might, but you might not. And then security, like I mentioned, very complex. We're now dealing with tons of dimensions of security. I showed you that complex architecture. Every single piece of that architecture is a vulnerability point. Our exposure has increased. In fact, OWASP came out with their new top 10 for large language models. Again, not new. Some of these things are not new, like data poisoning is not new or specific to LLMs, but is a bigger problem now and easier to do and easier to hide. We've got things like over-reliance, prompt injection. There's some really funny stories about prompt injection. Sensitivity information disclosure. Insecure plugin design. Excessive agency. Giving these models more access than you should be giving them. Right? Giving them access to delete code in your GitHub. Wild. So where are we going? I've talked a lot about where we've been, some of the big shifts. But I want to know, right? Everyone wants to know, where is this headed? So I'm a big advocate for open source. And I'm going to make a little bit of a case for open source and talk about kind of the shifts that we've seen so far. Especially in these worlds where we've got these large language models, people are trying to get to AGI, you know, we kind of want that to be a little bit more transparent. And most importantly, decentralized as much as possible. So we saw this big shift. How many of you used SAS before? Great, lots of people. I have as well. That was one of the first platforms that I used to do modeling in my statistics class. And every time we would go into these companies, they'd also have SAS. Why? Because it was super easy to use. End to end, you could deploy it, you could manage everything in one place. It's this closed source platform. Made it easy. We love easy, especially with how hard this stuff is. But then Python became more popular. And all the data science packages in Python started coming on the scene. And the rapid innovation and development was very compelling. We saw tons of companies saying, I want to build models in Python now. People coming out of college programmed in Python, not SAS. So we had this problem. We had all these models written in SAS, and we needed them to be moved to open source. In some cases, they weren't. But in a lot of cases, they wanted to because of the level of flexibility. We go back and forth between easy to use but constrained, innovative but complex. Seeing the same shift happen now. So we spent lots of time. In fact, one of our kind of taglines during our sales conversation is, we're going to help you get your models out of SAS. People loved that. But we want to be able to use these open source ecosystems. And it took a long time for these companies to build up the expertise and the tools and the systems to support them. We ran into problems like, okay, we're going to build this model, we're going to use Docker, because then we can make an image of our environment, and we can copy that image, that whole environment from our development environment into production. So it should be the same. We don't have these problems with broken, Python packages anymore. So we started developing more and more concepts in that vein. We're in the same point now. And I think in the next 2 to 3 years, we're going to start seeing more and more open source. OpenAI, closed AI, right, actually has a closed source model. And then you've got models like Llama, developed by Meta, which is open source, mostly. And so there's a shift that's going to start happening. Most of the customers we work with today, they're leveraging things like OpenAI. Their API, pretty easy to use, already integrated into our Azure environment, easy, get started quick. But this is a closed source proprietary model. And a lot of the concern is, what is happening with the data? Where's it going? And they'll tell you, they'll lay it all out for you. But truly, what's happening? How is this model architected? Did we test the model? How do we know that it's good? When we were doing those Docker transitions, the security team actually loved it, because they could look at that Docker image, and they could run security vulnerability scans on all the packages that we wanted to use. These models are a little bit harder. Try asking OpenAI what their true test results are on how they tested and interrogated their model. Is anyone familiar with Hugging Face or used Hugging Face? Great, couple people. I suggest you go. I think they just hit 1 million models on their platform. But they've got open source models on their platform that you can use. And these are small language models, some of them not. And so we kind of see this shift from this, what people are calling a God model, this big, ever-knowing model that can do all the things, to these more niche, smaller, domain-specific models that we can orchestrate together. So things that are very, very specific. I think of kind of your generalist versus your PhD, right? And again, with this shift will come complexity. It will create a lot more challenges in the short term for companies to figure it out. But I think it's worth it. Virtual humans. This one's fun. Has anyone seen the Reid Hoffman interviews? So Reid Hoffman is the co-founder and CEO of LinkedIn. He's using a tool called Hour One, which allows you to create a virtual clone of yourself. Is this a good idea? I don't know. Who thinks this is a good idea? Okay, a couple people. I like it. There's this virtual human economy that's happening, which is wild. You can make money off of your likeness virtually. And it's pretty good. In fact, Reid interviewed himself. That one's fun. And he created one of him back when he was raising, I think, his seed or Series A round for LinkedIn, which is a long time ago. And he was interacting with himself and asking past him to ask future him questions that might help him with his raise. It's pretty crazy. And it's fun. You know, I think we talk a lot about the ethical complexity that we're headed into, right? So this is definitely on the horizon and has gotten so much better. I mean, 2 years ago, Nick and I were playing around with it and it was so bad. But gotten so much better, so much better. If you want to test yourself on how rapidly the performance of these models are over time, give yourself a visual cue. Look at image generation from 2-3 years ago to now. It is drastic. And I know there's a lot of hype on AI. I know that. However, let's not forget the things that are real. I mean, there are real use cases in which AI is performing incredibly. And we've got to think kind of narrowly about that. What are the narrow, real things that are happening that we can leverage? And the rest is maybe aspirational, but let's keep an eye on them, right? Because these things are moving really quickly. I didn't mention this in the what has changed in the last 10 years because I wanted to spend a little bit of time on it now. There is a big paradigm shift happening with this human interaction with computers. So this is by Chris Becker. This is a diagram. He's got an excellent blog post on this. But we're looking at these shifts from how we engage with computers and machines, right? We're all familiar with like Alexa and Siri, and hopefully I don't trigger anybody's phone, but like we're familiar with kind of the voice agents that we've been using for a while. We're very familiar with the mouse and keyboard. In fact, too familiar with the mouse and keyboard and screens. But there's a big shift in how we're engaging with these things. And the reason we haven't fully moved, like imagine your entire workday with just voice. That would be crazy. But that's not to say that that won't happen. And I don't like to do that. Imagine a world where, but like honestly, this is pretty interesting. You know, and as these models get better, and they're better at different types of capabilities, like image recognition, video generation, voice, it starts to get better. And I can tell you that I'm using ChatGPT's voice mode daily. I use it all the time. I just ramble with thoughts or ideas if I'm on a walk, just to capture it. And it captures it flawlessly. I can have it engage with me. I can have it ask me questions. And it is a really nice mode. And we start to get into that creativity element. I can't really be creative with a mouse and keyboard. I'm not good at it. These slides, I'm notoriously bad at slides. So the design of these slides is fully my fault. But I'm very good at voice, and I'm very good at articulating things verbally. So for me, this is great. So as you're starting to think about how is this going to be used, this is often where I spend so much of my time. We build those models, we get over all the technical hurdles, we get them into production, they're running, we get approvals from security and architecture, it's all compliant, we're good to go, and then nobody uses it. That's happened to me so many times. And it's because we're not thinking about that end game. We're not thinking about who is getting that information, what are they doing with it, right? We gotta start there. So as we're building a machine learning model, an AI system, Whatever it is that you're building, start there. Think very deeply about that. That is a big problem, and I'd say context and nuance is the biggest problem. Because these models are nothing without context. How frustrating of an experience when you're engaging with these models and you just wish it knew. Just like, read my mind, right? Know what I'm trying to say. Know the context of the question. It feels kind of exhausting to like give it so much context. And that's, prompt engineering now, right? It's just like throwing up context. And now for agentic collaboration, the new buzzword of the year, agents. How many people have messed around with agents so far? Okay, a couple people, great. There's a lot of obvious tools and platforms that are kind of embedding these things into those systems. There's new platforms coming onto the scene to help develop these systems. What are they, right? Why are we calling them agents? So really, you can think about this as kind of like these 6 core capabilities. We've got goals set, sensors to detect and take in new information, memory that it stores, actions it can do, environments that it's existing within, and the ability to plan. I've got a goal, I'm going to plan something, I'm going to reference my memory, I'm going to try to get more information, I'm going to react to my environment. Robots do this today, right? But now we're thinking about these virtually. So what's the difference between me building a machine learning model and this agentic workflow? The key difference is it's holistic. These models, they create a prediction, cool, good, right? But how do we make that dynamic update over time? How do we get it to take action and do automation and react in real time to its environment, give it more context, make it aware? And this is exactly where things are headed. Has anyone played around with Devin, the AI code developer? Great. Or Cursor. Anyone played around with Cursor instead of GitHub Copilot? Right? These AI tools are actually very good at code development. And if you break down these big, complex tasks that we all do every day, we can actually automate a lot of it. I know that's scary. I'm not going to talk about what the future of our jobs look like. But I will say, very useful. And we can start with the really mundane, repetitive things. My big question I keep thinking about that sends me on these crazy spirals is, who is the arbiter of truth? What makes this thing good? I think about that question a lot. If you were to go into an organization and say, who knows the right way to do our supply chain? Who's the person? Who's the one person that knows the right way? You might have a couple people raise their hands, but most people won't, because they don't want to sign up for being that arbiter of truth. And I think this is one of the big problems we run into. If we're depending on these models to produce things for us, it's in the small nuances that it's getting it wrong, and that margin of error is getting smaller. And these things are going to get harder and harder to recognize. Is this good? Is this right? Is this what I want to use? And I often get a little bit concerned about people who are just entering the workforce, who may not have that level of context and nuance. Your senior developer will take a look at code, and in 4 seconds will tell you what's wrong with it, with very strong opinions usually. Whereas your entry-level developer doesn't know what to look for. They don't know what truth is. But that senior developer does, or at least he thinks so, or she thinks so. So this is the big question, right? Who is the arbiter of truth here? Is it us? Is it me? Is it somebody else? And how do we make sure we design those systems to do that? And I think this is where humans stay in the loop, is this arbiter of truth, the design, right? Back to our fun data science process. What does this mean for all of us in the room today? Well, a couple things. I can tell you that AI is pretty good at a lot of these pieces. I have built full machine learning models with AI. Wild. It's a little recursive there, right? But I will tell you that last piece, the interpretation of results, That is the hard part. It might get better. Who knows? 5 years from now, I might be wrong. But put the result into good use is a very vague objective, right? And it's good at finding significant patterns and trends using statistics. Let the computer do that. That's great. And I'm not by any means saying we should fully automate this process yet. I've seen a lot of new data scientists who are very excited about AI, who are building tons of models, where those models are not good to use in production. They may look good, but they're overfit, or there's a problem with it. And that's important to keep in mind. So oversight, again, arbiter of truth. Who is that? And how do we make sure that throughout this entire process, we've got those quality checks? And we can use AI to help us with that too. But at the end of the day, judgment and taste will continue to be a human thing. And I'll end with this, that the hard part of all of this is nuance and context. Where is it wrong? How is it wrong? And do you have enough context to be able to determine that? Thank you so much. I'm going to take questions. I tried to stop. Look at me, 9:42.
Oh, you got lots of time.
Yeah,
lots of
we
time.
have 18 whole minutes for questions.
So we got as Rehgan just said, we got lots of time for questions.